Hello everybody and welcome back to another forecast. This is my third video on this setup, and today is the last day of this major outbreak that we're seeing go across the United States. We saw, I believe, that two enhanced risks over here in the Great Plains states. Actually, 2 days ago there was this wind damage threat here for possible derecho. I don't believe that came to fruition, but there was definitely some strong wind damage. Next day we saw was our little wind thing here. They actually got upgraded to a slight risk, with Michigan wind damage being actually what ended up being the main threat for the Midwest, as well as some wind and tornado damage here in the Nebraska vicinity. Now we're on our last day, and the SPC has issued sorry, not high risk, moderate risk for really all hazards at play here. This is tornado, wind, and hail. See huge hash risks, basically centered here over Iowa, southeast Iowa, excuse me. Our main threat is definitely these strong tornadoes, but there is definitely possibilities of some very strong winds to be had with the system. And honestly, for Iowa, it's all hazards are at play here: big hail, strong winds, and obviously killer tornadoes. So what I'm gonna do is look at a bunch of different models here, kind of try to compile them together and understand what's going to be going on today. First of all, I want to look at the satellite data. So because we're so close to the event, I can actually see what's going on in real time. Right now it's 9:14 Central for me, and we can add reflectivity here, and we can see our morning storms from last night that are moving through, right? Here's our reflectivity. Kind of let it load a little bit. Here's last night's storms. All this convection. It's kind of in the morning hours. The sun's beginning to rise. You can see all these moving through. We get our satellite data. You can see all the clouds here. And what's happening is have your main complex of storms right in here. However, behind that line on this half, you can see it's starting to clear, getting those breaks in the clouds. For areas in the rest of the risk, aka these areas, you're just seeing basically no cloud cover at all. I mean, it's just very small area of clouds here in Illinois, but Missouri is almost completely clear. Illinois is almost completely clear, and really anything south, again, Missouri and Illinois, that's in your enhanced risk for tornadoes. But the main threat is gonna be Iowa because of this. Cloud cover is actually helping not have our temperatures rise too high. Here's my satellite. I can move to another sector real quick too. But you can see here too, not much cloud cover in any of the states in the rest of this risk area. That's each interesting to keep in note. And then yeah, there's all our clouds and basically completely open area here. So this is going to be very warm. And that's an issue for today. So right now I'm going to look at the model data. Here's our RAP model, 500 millibar map. This is from the 12Z run. You can see here, right at 12Z on the point of the RAP, you have this huge trough with an exit region here. You can see how the flow is stronger. So this is Kansas here. You can see 80 plus knots of flow, very strong flow at the 500 millibar level. And as this moves on through the day, it's going to keep injecting, and this strong flow is basically going to move right over our risk area, Iowa, and that's going to help initiate storms. That strong forcing aloft, that means so much air is moving, the atmosphere tries to fill it up from below. I'll move. I'll stay at the big sector for now. Here's our 700 millibar level. We'll stay at the big sector. You can see, again, pretty strong flow. Not really too many well-defined shortwaves. We don't really need that in this setup because of the fact that so much forcing is there, right? We don't really have that discrete possibility, or we do have the discrete possibility, but it's not as needed to have that shortwave to really kick it off. 850 millibar level, you can see lots of flow here. Here's Iowa again, 40 plus knots of flow. That will help rotate those supercells. 850 millibars, that's in like the 1 to 3 kilometer range, so that's in the atmosphere up. So that's going to help rotate those supercells in the lower levels, mid levels of the atmosphere. Looking at the surface here, you can see a big surface low right here. I'll zoom in a little bit too so you can see a little closer. At 12Z, this was centered somewhere around Kansas, and as this trough is ejecting in the higher levels, you can see this kind of take a more northeast approach. This is going to keep pulling up all these warm and moist temperatures. You can see the dew points here. I'm definitely infecting right here in Iowa where you want to see it. The rest of the risk area isn't really as good. One thing I'll look at is Illinois, this big dew point. The dews here are not very good. The moisture's not, the quality in Illinois is not as good, and that's a big reason why we're going to see later kind of a hole in the reflectivity over Illinois. But you can definitely see this good moisture surge into Iowa at the moment, and that's or forecast for the time we want to see storms. And we'll move on to the reflectivity part now because we can kind of see everything at play. One more thing though is Cape. We're gonna be seeing a lot of Cape along with these warmer temperatures. But you can see again, the main difference here over Iowa is that the temperatures are a lot cooler, right? So at 16Z, we're seeing 75, 70s. over in Illinois, 85, 80s in Missouri. That means that when we take a sounding, just see what I mean here. For tornadoes, especially, you want to see temperatures and dew points pretty close together. That means that early on, you're going to get that where the air will condense and actually form your storms. So this isn't the best example, but you can kind of see how far away these are, right? The way that we find where our cloud levels start is by taking a line from the uh, warm, sorry, the temperature line, going on a warm adiabat, which is kind of on these lines, so kind of like this. You want a mixing line from the dew point right here, then you get a height. You can probably already see it's right in here. Get a height, and this is somewhere around probably 800 meters in the air. We're almost a kilometer in the air at this point for our beginnings of our cloud levels. And if you want to have something on the ground, you don't want to have a storm starting at 800 meters up, about 2,400 feet. That's a lot, and you don't want to have that starting so high up in the atmosphere. So you want to see closer temperature and dew points so you'll get those tornadoes if that's what you're trying to forecast. For Iowa sector, again, this isn't actual real soundings because they're not technically really the best storm hour. You can kind of see the environment starts to pick them up and look better for it. Let's see. Yeah, in this case, you have our temperature and our dew point right next to each other, so air is immediately going to condense and rise. At this point, you still have that cap in place, but this isn't the sounding we're really looking at. Much better temperature dew point spreads them right next to each other, basically. Very good for tornadic activity. And the Cape here, Plenty of Cape is going to be in this region. You can see our destabilization begins somewhere around 1 p.m. and right around noon, about lunchtime, 1 p.m. 18Z. That's right in here. You can start seeing that cap break right along that dry line or dry line kind of setup. Maybe the cold front. We'll call it a dry line cold front. I don't know. Either one. That boundary here, that's going to be where our main forcing is. Look at our Cape. You can see that destabilization really starts right around 4 p.m. and that's when we get our big widespread. So, all that reflectivity, all those storms are going to start forming right around 4 p.m., 3 p.m. You can see that destabilization right all along this thing. That's when our main storms will start. You can see them kind of fizzle out. And again here, the lower moisture quality in Illinois kind of means that Cape dies out a lot more in this area, whereas in the north and in the south, that kind of persists for a while. So I'm going to look at the HRRR now just to see better reflectivity. Here's 18Z. As we said, that's right about when storms are going to start firing. And there is our firing at 18Z. Actually, I'm going to go to pivotal weather as well so we can see. Maybe I'll use some soundings from this as well. Around 18Z, 19Z, that's when our storms really start firing right here. So I'm going to take a sounding right ahead of these so you can see the environment they're going into. 4,000 joules per kilogram of Cape, 200 plus of 3 Capes. When at lower levels, you're plenty of destabilization those lower levels. This may be a little bit enhanced because I kind of see this, but again, good moist layer, up to almost 700 millibars. And definitely shear in those lower levels, lower few kilometers of the atmosphere. A 0 to 1 shear, again, it's not amazing, but you can see here, definitely that curvature. The SCP is pretty high here. This already says potential has a type of PDS tornado. The parameters are definitely here, and the environment is definitely good for tornadoes, especially with those early, more discrete storms. I'll take one 2 hours later. We'll take one again from Iowa. Let's see. Yeah, same thing. Not as much Cape, free Cape, or regular Cape, and not as good wind profile. So the best storms for tornadoes would definitely be those early storms, those early supercells that stay more discrete. Look at the Missouri area. Let's see what the environment these are going into. This is more supercellular, but again, because of Missouri being hotter, you can see 86 degrees and 66 degrees, and that's a huge temperature dew point spread. 20 degrees is a lot. What's going to happen is that those storms, it's LCL, that's our cloud layer, that's almost a full kilometer. That's a full kilometer up into the atmosphere at this point. This hazards are more of hail rather than tornadoes because they're not as close to the ground. Still, though, the wind profile does kind of show our supercells. You have that kind of M shape I kind of like. You have the shear in the lower levels as well as that backing and then jetting off the winds to go up higher in the atmosphere. So still supercellular in the more Missouri area, but that's probably more of a hail risk. And we do kind of see that here in the outlook. So those early storms are going to start with hail. By the way, the hail is a huge threat for all this as well, just because of our amount of hail growth zone cape. You can see the two lines here, -20 and 0. That's when our hail really grows. You can see in this Missouri setup here, lots of cape in that region. I'll probably get something similar with the Iowa setup as well. Again, bunch of cape there. The Iowa setup, again, that's more of a tornado area, but we could still see very strong hail with these supercells. As we go later on into the night, I'll take another sounding, do it at 1Z, that is 8 p.m. Central Time. I'll take a sounding from this Wisconsin area. Look at this first. Definitely good for tornadoes. This one might be getting messed up a little bit. I'm not sure about the cap in that case. Let me look at the wrap model for this one. We'll take a look at our northern storms. Take one right here. This is 1 p.m. or sorry, 8 p.m., 9 p.m. We'll take one 9 p.m. The Wisconsin storms. I'll also look at one from. I'll look down here in Missouri. But there's more dying storms. We'll take one from the wrap model. Understand what they still look like. They should also pose threats. Here's our Wisconsin setup. Not as much cape because you're in the overnight hours, but it doesn't really matter. You still have that very good shear. Here's our 0 to 1 kilometer, and definitely shear right there. In this case, it's a lot more speed shear. You can see how in these wind barbs here, they're not really turning as much, and they're more just speeding up. I mean, you can see it's very fast here. The more speeding up winds here, so that can be more of a wind threat, especially. But you still do have that 3 cape. Still have decent cape in that hail growth zone. Again, still good for our tornado activity, but more so wind damage in this case. In those southern storms, you can see they still have some supercellular characteristics, setting off of winds and kind of some shear here, kind of picking at straws there. But definitely not as good cape, and these storms will definitely start dying. Our main persisters being more in the Wisconsin area. That is actually shown by the CSU machine learning program. I've been looking at this for a few days just to see how accurate it's really going to be. They definitely like the Wisconsin area for tornadoes. The Iowa vicinity actually is not nearly as potent in this machine learning program look. And the wind probability, again, this seems to have all the hazards more so in Wisconsin, which is definitely interesting to find. Last thing I want to look at is the HREF ensemble. So I looked at this in yesterday's video. I do quite like this model. I'm going to be looking at is the updraft helicity probabilities of that. This is a combination of 10 plus models here that are all seeing where there's going to be rotation in the atmosphere. That is their updraft helicity. That's rotation. And you can see in our morning MCS here, all this updraft helicity is going on with it. So as this jets off, it's going to get rid of all that cloud cover. And you can see behind this, that's where you get that first destabilization in those early supercells back here in Nebraska. This is 19Z. You can already see 70% updraft helicity chances here in that border between Nebraska and Iowa. Right here, that's our Nebraska. That's our Iowa. Not the best drawings. You get the point, though. Just so you can kind of see those. Even I'm having some hard time seeing the lines. You can see here's our 20Z. I'm already getting at 70%. I'll keep the H triple R up if I can. Already seeing that 70%. Here's 50%. I believe it already goes to 70% very early on. Very good chances of seeing the updraft helicity in this area. For that more southern mode, there is still chances according to some of them, and there definitely will be rotation with those supercells, but we're not going to see as much rotation for tornadoes in that vicinity. And we can see as the night goes on, again, updraft helicity is still there, but not nearly as strong. For the Wisconsin area, more so. Up there. East northern plain. There we go. You can see Wisconsin in this one. Let it load real quick. Updraft helicity for Wisconsin. Let me update with the probabilities. That still does persist way into the evening hours in Wisconsin, more so because all of that low surface low is pulling all those warm temperatures up there, and that will help with the cape in that area. So even at 10 p.m., we have a 50% chance at least of updraft helicity in that area. So definitely pretty good for those hazards at play as well. I do like that look for updraft helicity, and I do like this model compilation. Look at surface-based cape as well. I'm curious about the HREF for this. It has that destabilization in Wisconsin for quite a while. Max, I don't like to look at max cape usually, but mean cape is a pretty good value to go with. You can see here a lot more cape in more of the southern storms, but we really need is that more discrete destabilization in the Iowa vicinity. You can see that is definitely moving in there. I think this is kind of underdoing Cape, which is weird because it's an ensemble, but I do think it's underdoing Cape. A lot of people are, a lot of obviously all the forecasters are very adamant on the Iowa setup here. That's just where our forcing best, and that's our wind dynamics are best for tornadoes. But any storm mode here that can congeal into a line could keep moving to the east. I'll look one more time at the how this will go through again. Those early supercells somewhere around lunchtime, 1 p.m., 2 p.m. especially, 4 p.m. here. This is around 12, 1, 2, 3, 4. And then around 5 p.m. you should have a huge line of cells. Many of these could be tornadic, definitely rotating according to our parameters. And after that daylight heating is gone, we kind of see a mass breaking a lot of these storms, especially in this more southern mode. This could pose more of a wind threat. Again, likely all these storms are mostly hail. You can see the kinks here, all this reflectivity. The northern mode here, that's where the rest of our threat is. Could see some rotations in that huge line. Could see some QLCS tornadoes. I can actually see this through surface vorticity. Our vorticity is definitely strongest in that Wisconsin mode. A little bit scattered when you look at it, but it is strongest up there. The NAM doesn't show this as well. NAM actually seems to be, here's if it's a little more aggressive or less aggressive. Seems a little bit less aggressive than the HRRR. Definitely more of a wind damage threat in this more southern mode. Wind damage all across, but definitely that discrete elements in the Iowa vicinity, and then a wind damage movement towards that 7 p.m. hours. Is there anything else I can look at here? That's our main threats. And surface vorticity in 3 Cape. Not as good for QLCS tornadoes in that more Wisconsin area, but if you look at all our surface lows here, definitely very potent. You can see maybe a secondary surface low, or that's actually the cold front there, but lots of warm convection for Wisconsin, and then temperature dew point spreads up here are very good. So you could see some better results for that Wisconsin area. HRRR doesn't like this as much. It definitely shows a lot less moisture quality, so it's a kind of depends what's going to be in the mixture. So there's the NAM, which is a lot more aggressive with the dew points. HRRR is a lot more aggressive with the huge lines here. So what comes to play, we'll see later, but definitely a huge threat. So I'm going to end this video too. So huge threats here. Thank you for watching. I'll be looking at this later, seeing what's going to actually come out of this. It's definitely a very potent day, and tornadoes are definitely a play for Iowa especially, but really anywhere across this risk area is also a threat for any tornadoes. You never know what's going to happen. Storms kind of do what they want to do, and you don't know where they're going to pop up. So tornadoes are at play. Hail early on, tornadoes as those stop being as much hail, and then wind especially into the more evening overnight hour. So thank you for watching. I'll see you in the next video. Again, I'll probably not post anything for tomorrow, but we'll be seeing. I'll look a little bit into these other threats. Might post some community posts. Please stay posted for those community posts. I post about 10 times there. Please pay attention to my community posts. I do plan to post on them more often, and I should see those out more. So, and thank you for watching. I'll see you in the next video, and have a good day.